Hey guys, Mr. Mice is here back with you on second part of a video on related rate story problems. So I've got two more examples for you for related rates. I just wanted to make sure that I was able to have enough time to explain these thoroughly so that way you guys can understand what we're doing with these. So I've got another example here. This time it does not come with a picture, but we'll go ahead and I'll let you read through it and then I'll go ahead and get started. So here we go. Now what I like to do is make a picture. So I love making a picture. Making a picture helps me out. The police officer is going this way. Make an arrow to tell me which way he's driving. And then the other car at the intersection is traveling away from the police officer. And then there is a distance between them like that, right? Now we don't know everything is changing, right? Because the police officer is going this way, the car is going this way, and everything is changing. So I'm going to go ahead and label all of these X, Y, and Z. And I know that the change in time of this Z is going to be dz dt. The change in direction of this one is dy dt, and in this one is going to be dx dt. Now, just a point of note here, when we look at this, and if you think about the police officer driving here, the police officer is getting closer and closer to this intersection, right? And the distance y, is that getting smaller or larger? Well, you should notice that this distance that the police officer is getting closer and closer to the intersection, this y value is getting smaller. So that means the change, the directional change, is negative because we're getting smaller. So this is a negative rate. Whereas this value, x, is getting larger. The car is going away from the intersection, so this rate is going to be positive. So we got to make sure that we account for that when we do our work. So we're going to start by making our equation. X squared plus y squared equals z squared. And we're going to go ahead and take our derivative. 2x dx dt plus 2y dy dt equals 2z dz dt. Notice here that even though I know that x is or y is, I know that y is 0.6 and x is 0.8, and the police officer is traveling dy dt at 60 miles per hour. I'm going to put that negative in there because it's going down. And dz dt is getting larger there at 20 miles per hour. Even though I know this, I only know this for one moment in time, right? These values, y and x, they're changing. So I'm not going to enter in these guys until after I do my differentiation. This is a really important part, guys. Do not enter in things that are changing until after you've done your implicit differentiation. Okay, now that I've done it, I can go and plug stuff in. So I know x is 0.8. Do I know dx dt? I do not know dx dt. I believe that's what we're looking for. All right, do I know y? I do know y because I said so. it's 0.6. Bad joke. These are the jokes, people. I'm going to put in my negative 60 here for dy dt. I do not know z, so I'm going to go look for that in just a second. I'm going to say, z, where are you? Where are you, z? Z, what up, z? Where are you? Well, I'm going to go ahead and on the side here, I'm going to figure out what z is. So I'm going to say 0.6 squared plus 0.8 squared equals z squared. And I'm going to go and solve that for z, and I'm going to get 1. So I know that I know what z is when these are happening, and that's 1. And now I'm going to go and solve this. So I'm going to get 1.6 dx dt, and I'm going to multiply this out, which is 40, and subtract this on this side. So that's, or actually I'm subtracting over, but I've got a negative here, right? So I've got 40 plus 72 from there. And when I divide 1.6 over, I'm going to get dx dt is equal to 70 miles per hour. All right. That's not good enough because I really want to write my sentence in context. So we're going to say, I'm going to go ahead and write this down. I'm going to write it down here. Okay. When the police officer spots the car, the car is increasing at a rate. Remember I told you in the last video, use this word, they like to see that word, is increasing at a rate of 70 miles per hour. The car's distance, I guess you could say the car's distance from the intersection you can say that is increasing at a rate of 70 miles per hour. You can say that it's traveling. You can say it's traveling at a rate of 70 miles per hour. I like that. That kind of makes a little bit more intuitive sense with what you know. But try to use this word rate. Just don't say the speed is a rate of 70, because if you say the rate of speed, that's actually acceleration. So you got to use the word rate, but be careful on how you use it. Okay, because this is the rate of change of distance here. Okay, all right. Let's look at our last example. Go ahead and read it, and then I'll go ahead and pause so you can read it, and then I'll go ahead and get started. Okay, we're given a formula here. What's nice is that we're given a formula, so that's what we're going to be using. But we want to label what we got here. I'm going to go ahead and use yellow here so it pops up a little bit better. And we know that this down here, this is R. And this is the height, right? And we know from the problem that the radius is twice the height, right? So the radius is equal to 2h. Another way of writing that is that h is equal to r over 2. Okay, so this is a secondary relationship that we're going to need here. So what are we looking for, guys? We're looking for, okay, so what do we know? We know that gravel is falling at a rate. Now we see a cubic here. A cubic's going to tell me this is volume. So I know right away this is dV dt. And that's volume. So it's 10 feet cubed per minute. And I'm looking for, find the rate of change of height. So I'm looking for dH dt. I don't know what that is. So I know I'm looking for dH dt, and I've got two variables here. I don't want to deal with both variables. I'd like to just deal with the h, because I have no idea what the rate of change of r is doing. And if I did multiply this, I'd have to know what dr dt is, because I need to plug it in somewhere. So I don't want that r to begin with. So what I'm going to do is I'm going to substitute 2h right here, and I'm going to substitute that in for r. All right, so that'll be the first thing I do. So let's go and do that. We're going to say v equals 1/3 2h squared times h. I'm going to simplify that a little bit, and that's going to give me 4/3 h cubed. Okay, so now I've got things in v's and h's, and I'm going to go ahead and do my implicit differentiation. So let's go and do that. We're going to have dv dt equals, we're going to use the power rule here, that 3 is going to come down. Okay, 3 times that's going to give me 4h squared times dH dt. Remember, we're doing it implicitly. All right, so now we're here. Great. We know dV dt. We know that. That's 10. For h, do we know h? Well, we don't know h, but we know the radius at this time is 6. And we do know that h is equal to r over 2. So h is going to be 6 over 2, which is 3. So we do know that this is 3 at the time that we're looking at. And we don't know dH dt, that's what we're looking for. Well, this doesn't look too bad of an equation to solve, right? Did I miss my pi somewhere? I think I left out a pi. Who wants to leave out pi? Pi is so good. We don't want to leave out pi. We'll put this pi back in here. Now we're going to divide that over, and we're going to get 10 over, let's see what that's, 9 times 4 is 36. Divide the pi over, we get 10 over 36 pi. We reduce that, and we get 5 over 18 pi feet per minute. Okay, so I'm going to write this as a sentence. The height of the gravel pile is increasing at a rate of 5 over 18 pi feet per minute. All right, so there we go. So that's how we do related rate problems, guys. So hopefully this helps those of you that aren't in my class. Those of you that are in my flipped class, you know, we've got 4 examples with these 2 videos. I know they took me a while to do, but you know, I wanted to spend some time and show you the proper procedure, because really, if you do the procedure correctly and you continue to do it and you get more practice, these problems really aren't that bad, because they have the same procedure in mind. All right? Okay, we'll see you guys later and next time. Bye-bye.